Hello everyone, and welcome back to Revit Snippets. Great tips you can learn in just a few minutes. Today's video is brought to you by CAD File Explorer, the easiest way to see, manage, and clean up AutoCAD files in Revit. Get your free copy today by following the link in this video description. Today, let's see how we can use Dynamo to obtain the X, Y, and Z coordinates of model elements in the project coordinate system, and then write these X, Y, and Z values to element parameters you can then use in schedule, like this one. So for example, when I select this chair here, it has X, Y, and Z parameters, but they are empty for now. When I go and open Dynamo, open the script, run this, you will see many of those objects now have their X, Y, and Z coordinates detected and populated on the fly. Other things like walls haven't got their X, Y, and Z coordinates because they are line-based. But anything you can place in a model using one click or a point will get their X, Y, and Z exact coordinates from this Dynamo script here. Things like TV, shower stalls, skylights, windows and doors, all of that stuff. So if you want to run this Dynamo script immediately, just go down to this video description and use the link there to download the script directly from my website. Otherwise, if you have a bit of time, I will walk you through now step by step exactly how to create this script yourself. By the way, if you are new to this channel, make sure to subscribe now, because we do tutorials like this every single week. Okay, let's begin. If you haven't already, go to Manage and then click on Dynamo. From here, we can choose to make a new definition, so I'll choose New now. And before we forget, let's change the run mode from automatic to manual, just so it won't crash Revit from time to time. That's dangerous. Also, let's save the script before we lose it in any way. Let's call this one Right Coordinates to Element Parameters. Save it now. Okay. The next step is to select the items from the model that we want to write coordinates to. One of the easy ways is to do from categories. And here you can select one category, for example, furniture. And then you can get all the furniture objects in the model. However, this is not working very well in our case here, because we have not just furniture, but also other things like casework, furniture system, doors, windows, and so on. If we do it using this categories node, it will mean we have to copy this one several more times, and then make a massive list of categories, and then get all the elements from each of those categories. That is not very easy, and I usually prefer to have a cleaner graph, so let's not go down this route. Instead, here I have Visual Studio Code, which is my choice for a Python script editor for Dynamo. If you want to know how to set this up for it to work well with Dynamo and Python, check out my other lesson in this video description, where I explained how to install the Visual Studio Code program, how to import the Python and Revit libraries. All of that will be in there. For now, let's assume you have everything like that set up, and let's dive straight into selecting elements. So I have here just everything in my Python template for Dynamo. If you are new to all of this, there's also one of my other tutorials that you can get to from the video description below, which will give you a basic understanding of Python just enough to make it work with Dynamo. So assume that you have already watched that. Let's start selecting some elements now. Let's make a first variable. Let's call this elements. And this will be the collection of elements I can get from filtered element collector on the document object DOC. And because I want to get all the family instances in the model, regardless of which categories they belong to, I can now do of class. And then family instances. That's it. Actually, not the S, just family instance. And now I can output elements, as simple as that. We can now copy all of this and drop in here a Python script node. Open it now by double clicking and paste everything there. Let's save it, close, and run the script. So straight away you can see Very quickly, we have coming back to us 454 items, which are all the family instances that we have in the model. Next up, let's get the location of those objects. I will go back to Python now and put in here a for loop. So let's say for lm in elements, we want to get the location point of the lm. Let's call this one log point like that. And this will be lm.location.point. To see this in the output of this Python script node, I want to make now just a quick watch list that is now empty. And coming down here, I can say watch.append log point. Coming down here for the out variable, let's use watch as what we want to see. So now again, copy, edit, paste, and run. There's a warning there already, and it says NumTile has no attribute points. What that means is this, let me show you. The error is on line 44. If I go to line 44 now, that's the line where I obtain the location point of the item. So for some elements like a curtain wall mullion or a floor, they don't really have a particular single location point, because remember, things like floors are defined by sketches and things like mullions are line-based. They have a location curve. In that case, for those objects, the location.point command will return a none value. So before we want to get the point from the object location, we need to check first if the location is something else, not just no or nothing. So let's try that now. Let's say location is lm.location like that, same as below. So if location equals none, continue. That means if this element doesn't have a location, we continue to the next item in the for loop and skip the current item or the current element. Okay, let's copy this again and test it out. Here we go, no more errors. If I now go a bit further down, I can see coming back to me is 403 location points. That means about 50 items were invalid for this operation, which is fine. We only want to get items that are defined by location points anyway, so then we can define the X, Y, and Z shared coordinates of those points. So moving on, let's go back to Python now. The next step is to get the shared coordinates of those location points. And for that, we need to get a new object from the document. Let's call this new object project location. And it will be defined as doc.active project location. It's a special Revit object which holds the shared coordinate system and so on that we can use later on. If I want to see it, I can copy this one and make it the first item in the watch list. So copy it there, paste it here, run it. You can see now we have one project location object, even with an element ID. That's nice. So we know that line is working. Next step, we need to use this object to find the shared coordinates values of this location point. That's very easy to do. Let's go down here now and call a new variable x. X will be equal to project location dot get and then project position. And here we will pass in the location point from before. I'm going to append X to the watch list and see the result. There's an error there because I actually didn't put this right. Instead of get underscore, we should just say get, like this. Let's try this again. Here we go. So we have now different project position objects, each one coming from one family instance. Now this object, it has the X, Y, and Z values we need. So This one actually shouldn't be called X. Let's call it position. And then X will be position dot east west. Now let's see what X looks like. Paste it there, run it now. And there we go. We have now X coordinate values of those objects. We can now check if these values are correct. So instead of just appending X to watch, I can now append a list of 2 items. The second item will be X, but the first item will be the element itself. So let's see how it looks like. Here we go. We have a few items there to see. Let's try and choose one to check. How about this tree here? I can click on this little green button to see it. And then select by ID to get it. So 946759 is this one. Let's isolate it in the view. And we can now drop in here a spot coordinates to see its location point in the shared coordinate system. So apparently that is wrong because that number there, 101, is not the same as -31029. Here's the reason why. When we do things in Python like this, it's using methods in the Revit API, and these methods, they work with the internal Revit unit system, which is feet and inches. So now we need to have a way to convert this X value from feet and inches to a metric value. For that, we need to use this method here. Actually, no, this one below. This method will convert a length value in the internal unit system to the equivalent in the metric system. So I can now just copy this, paste it there, and use the brackets to pass this value in feet and inches to the method. The method will run and it will return the X value in metric format. So with that done, let's try this again here. And certainly enough, we have an error. This is to do with the display unit type we use on line 39. Let's look at line 39. It's this line to do with unit conversion. This is because we are using here Revit 2022, and in this version, the API for converting between units in Revit has changed. I can change this now to fix it for Revit 2022, but that means the script won't run for Revit 21 and earlier. So instead of doing that, let's make sure this will be responsive to the Revit version that I'm using this script on. To make that happen, we need to find out the Revit version first. So let's go to here now and call a new parameter Revit version equal app dot version number. This will be a string, so I need to convert it into an integer. Let's do int and wrap this like that. I can now go to here and maybe see what Revit version that is. So before doing all of this, let's Ctrl C to comment this line out to disable it and test this script again. Of course, X is not defined, so we need to also remove this item there. And rerun the script here. Here we go. So for now, I don't have X values anymore, but the key thing is I now have the Revit version, and that's 2022. Let's now go back to here, Ctrl Z to bring things back. And now let's make sure that this line will be responsive to the Revit version up here. So how about we do if Revit version is greater than 2021. We then do something else. If not, we can use this old method of returning this whole thing there. For Revit 22, we need to copy this line up there and change it. It's simply the case now to change this text here from display unit type millimeters to unit type ID dot millimeters. Here we go. Let's test it out. So copy paste again. And now it's working. As you can see, these are now actual metric values. If I look at the item at index 200 again, this tree there, you can see now the X value is now exactly the same what we're seeing in the model, minus 31029. This one, of course, is a bit more involved because the routing is a bit crazy there. We actually need to route this one off. So how about we go back here and type in route and then wrap that into brackets. So Control C, Control V again now. Run this again. And now we actually have routed values to the nearest integer. That's perfect. So now that we have got it working for X, let's do the same for Y. I can go here and copy this line down. Change the variable name here to Y. And for east-west, let's change that to north-south. Just like this. And one more copy down for Z. This time, let's change this to elevation. And now you guessed it, we're going to append Y and Z to this same list. And that list will go into the watch list. Let's now see how it turns out. Copy, paste there, and rerun this. That has now given us 3 different values for each family instance. Let's get back to our favorite object, the tree here at index 200. And you can see there, the Y value is correct as seen in the model, and the elevation, even though not showing there, should be correct as well. Okay, moving on, we need to have some parameters in the element to write these values to. In here I have already made them. If I now select one object here, it has parameters for X, Y, and Z coordinates. But let's do it again so you can see the process. I will not undo until before I made the parameters. So if I now get this tree again, there's nothing there for X, Y, and Z. To add these 3 parameters, we can go to Manage, go to Shape Parameters now. And in here, make sure you have selected the right shape parameters for your project. Otherwise, choose Create to make a new one. For me, I have made this temporary file here, just for this tutorial. So in here, it's just an empty file. I need to firstly go to Groups and choose New. Let's call this group Coordinates. And in this group now, we can make new parameters. I'm creating them here as shape parameters because later on we will need to schedule them. And shape parameters will be good for that purpose. Let's choose New now. And I'll simply call this one X. Make another one now, choose Y. And the third one, let's call this Z. And we're good to go. I can then return to project parameters here and add these 3 new parameters to this project. So select X first, check all categories there, make sure it's an instance parameter now, and do the same 2 more times. We add now the Y parameter to everything as an instance object parameter, and finally the same goes for the Z parameter. Check all instance, okay, bing bang boom, okay again. Now when I select something in the model like this tree, I have X, Y, and Z. So far so good. Let's go back to Python now and make use of them. We now need to select for each of the item here, the X, Y, and Z parameter. So let's make a new variable called xparam. And this will be lm.lookup parameter by the name of X. Copy this line down 2 times. I will call this one Y. And the last one Z. Here we go. With that done, I can then go down here and say for x param, set the parameter for this object to be the value of x. And the same goes for y. Yeah, just like this. And the same for z. Now let's copy this here and test it out. Just so you know, it's going to raise an error, but I want to show you the error so you know what's happening. Run it now. And it says, cannot attempt to modify the model outside of a transaction. Apparently, to modify something in the Revit model, we need to open something called a transaction. Let's do it now. If I go to here, I can say tr equal transaction in the document doc, and let's name this transaction coordinates. I can then start the transaction like this, tr.start, and when that's done with all the elements there, I can say tr.commit. Otherwise, no changes would be applied to the model. So copy this now and paste it there. Another error, none-type has no attribute set. That means for some of the objects in our list, they don't have the x, y, and z parameters. And that's because of this. Let me show you again. When I go to add parameter, I could choose the categories to add the parameter to. Some objects, they don't even belong to any of those categories. Anyway, in that case, I don't think we are interested in those objects anyway. So let's just skip over the error to proceed with the rest of meaningful elements. To skip over the errors, we need to check if an object has these three parameters. So how about we say if not x param, or not y param, or not z param. Then that's an object we don't care about. Let's just continue to the next item in the loop. Copy this now, paste it there, and run it. So a message here about changing elements in groups. Essentially, some elements are in groups, and because different groups have different locations, the elements inside them will get the different x, y, and z values as well. In this case, cannot be helped, so let's just ungroup them to proceed. This is also fine. Some group no longer has any elements, so there's no point keeping them anyway. And that is now done. If I now expand this now, all of these values, x, y, and z, are now in those objects. Let's say I want to select these three again. And you can see now we have x, y, and z. If I go back to my level 1 floor plan, and check out this chair here, for example, x, y, and z is there as well. Same for this stool. Same for this column. This wall, however, wouldn't have x, y, and z because it's a line-based element, not point-based. But things like chairs and sofa should be working very well. Let's do a schedule as well. Let's go to View, Schedule, and choose multi-category to see many things. Choose OK. And here we can say we want family and type name, as well as x, y, and z values. Let's sort the list now by family and type and see what we've got. As you can see there, many of them have the x, y, and z values. The rest do not, because they are elements we are not typically need to assign coordinates to. For example, curtain panels, or railing, or the landing of the stair. Some walls, of course, wouldn't be done. But anyway, in terms of family instances, we have captured all of them. For example, pile capped, shower stall, skylight, doors and windows, and so on. They all have been done. If you have problems following this tutorial and just want to download the Dynamo script to run it on your project, simply go down to this video description and use the link there to download it directly to your machine. If you see the power of Python in Dynamo from this video and want to do more of this yourself, also go down to the video description and find a link there to join my full course on using Python scripting in Dynamo for Revit. For now, enjoy saving time with this Dynamo script, and I'll see you in the next lesson.